Our next step is to set up user preferences for the My World app. As you recall, Apple considers applications that perform simple, highly defined tasks as utility apps. The Weather app, for example, deals only with the weather data. The Stocks app only with stocks data. One characteristic of utility apps is that the user can change aspects of it. In Weather, for example, the user can add and change what city's weather appears. In Stocks, the user can change which companies to list. In both cases, the users can make these changes in the flip side view. In Stocks, for example, the stocks are the main view, and the ability to change companies or move them up and down the list is in the flip side view. In Weather, the weather for the city is shown in the main view, and the controls to change the city and move them up and down the list of cities is in the flip side view. The My World app also performs a simple, highly defined task, and is thus considered a utility, and that's why I based it on the utility application template. With My World, the idea is to enable the user to enter his or her own words for the falling words here, as well as change the speed of the animation. For these functions to work, we need to enable the app to save the data that a user enters, so that the next time the user fires up the app, the text is still what they had last entered, rather than peace on earth. So we would put those controls for the user to enter the text and speed, which are called preferences for this app, in the flip side view here. Here's where the user will be able to enter the text and change the speed. Most people these days have spent enough time around computers that they know what I mean when I throw the term preferences around. On your desktop, for example, you can set preferences at the system level for things like security, screensavers, printing, file sharing. You can also set preferences for applications. You can set all sorts of preferences in Xcode, not to mention all the preferences in your browser and word processing programs. The latter are application-specific settings used to configure the behavior or appearance of an application. On the iPhone or iPod Touch or iPad, application preferences are supported as well, but the iPhone displays all application-level preferences through the Settings app, and that also includes the iPod Touch and iPad. And whatever separate settings feature you come up with has to function within the framework of iPhone's Settings app. In effect, the Settings app makes you color within the lines. Now here are some of the guidelines for user preferences on the iPhone or iPod Touch or iPad. Number 1, you would use the Settings app if you have preference values that are typically configured once and then rarely changed. You leave the task of setting preferences to the Settings app, and on an iPhone, this would apply to things like enabling or disabling Wi-Fi access, setting wallpaper displays, setting up mail accounts, and any other preference you would set and then leave in place for a while. Now, you would offer a way to change your settings in the app if you have preference values that the user might want to change regularly. The iPhone's Weather app is a good example. Suppose you want to add another city to the Weather app. It's really easy to do. All you have to do is tap the info button at the bottom of the screen. The view flips around, and you can add it to your list of cities. Or you can say, delete Berkeley, as I'm about to do in this screen. That's a lot easier than going back to the home screen, launching the Settings app, adding the new city or deleting a city, and then launching the Weather app again. And you will probably want to change cities while you're traveling. So this type of preference really belongs in the app. With the My World sample app, we could go either way. We could set up preferences using the Settings app, assuming that they're rarely changed by the user, or we could set up preferences from inside the app, assuming that they're changed frequently by the user. And to make My World a better example, I'm going to show you how to do it both ways. First, let's talk about what you will use to accomplish this. In the Foundation trilogy, an epic science fiction series, Isaac Asimov and his editor John Campbell devised the concept of mathematical sociology, which is analogous to mathematical physics, in which the law of mass action can predict the future, but only on a large scale. It is error-prone on a small scale. While the Foundation framework that you have to work with has really nothing to do with that, except that it too was devised to predict the future, what your app and many other apps may want to do. And it works on a large scale, while remaining somewhat error-prone on a small scale, or in the hands of inexperienced programmers. The Foundation framework provides a set of useful object classes in primitive form, ready for you to flesh out, and it introduces several paradigms that define functionality not covered by the Objective-C language. Think of it as providing the plumbing features such as data storage, text in strings, dates and times, object creation, disposal persistence, and common internet protocols. In any case, the Foundation framework was designed with these goals in mind: to provide a small set of basic utility classes, to make software development easier by introducing consistent conventions for things such as deallocation, to support Unicode strings, object persistence, and object distribution, and to provide a level of operating system independence so that you can enhance portability. And we've already used some of the Foundation framework's useful utility classes for text and strings, such as NSString. It provides object-oriented storage for an array of bytes. And we've also used the ones for object creation and disposal, such as NSAutoReleasePool in the main function, which is used to implement the delayed release feature of the Foundation framework. We've also used an NSTimer to send a message to another object at specific intervals to do the animation on the screen. But now we will use other useful classes for application coordination and timing, such as NSNotification, NSNotificationCenter, and NSNotificationQueue, which provides systems that an object can use to notify all interested observers of changes that occur. We will also use NSDictionary to provide storage for our preferences. And we will use a built-in, easy-to-use class that lets you read and set user preferences from your app, called NSUserDefaults. The class is also used by the Settings app. We'll use NSUserDefaults to read and store preference data to a default database using a key value, just as you would access keyed data from an NSDictionary. The difference here is that NSUserDefaults data is stored in the file system rather than in an object in memory. Objects, after all, go away when the app terminates, and we want this data to persist. Storing the data in the file system rather than in memory gives you an easy way to store application-specific information. And with the help of NSUserDefaults, we can easily store the state the user was in when he or she quit the application. Or we can store something simple like a text string, which just so happens to be precisely what we need to do for the MyWorld app. To understand this, let me talk about dictionaries, which are very cool. They are like the cousins of arrays. Both do pretty much the same things, but dictionaries add a new level of sophistication. You can store an object in a list and assign a key that you can then use in the future to retrieve the data, eliminating the need to manually move through long lists of objects to find what you're looking for. You can use dictionaries to hold both property list objects, which we do later on, as well as application objects. And like arrays, dictionaries are made up of pairs of keys and values. And a key-value pair within a dictionary is called an entry. Both the key and the value must be objects. So each entry consists of one object, that is the key, and that's usually an NS string, and a second object that is the key's value, which can be anything, but in a property list must be a property list object. And within a dictionary, the keys are unique. You use a key to look up the corresponding value. And this works just like your real-world dictionary, where the word is the key and its definition is the value. So, for example, if you have an NS dictionary that stores the currency symbol for each currency, you can ask that dictionary for the currency symbol, which is the value, for a particular type of currency, such as the euro, which would be the key. You would look up euro as the key, and you would get back the symbol, which is the value. Although you can use any kind of object as a key in an NS dictionary, keys associated with property list objects in a dictionary have to be strings. You can also have any kind of object for a value, but again, if you're using them in a property list, they all have to be property list objects as well. NS Dictionary has a couple of basic methods that you'll probably end up using regularly. One is count, and this method gives you the number of entries in the dictionary. Another is object for key, and this method gives you the value for a given key. You also have the methods write to file anatomically, which writes a representation of the dictionary to a file, and init with the contents of file, which essentially reads the dictionary in from a file. Now remember, if an array or dictionary contains objects that are not property list objects, you can't save and then restore them using the built-in methods. Just as with an array, a dictionary can be static, as in NS Dictionary, or mutable, as in NS Mutable Dictionary. NS Mutable Dictionary adds a couple of additional basic methods. setObject for key enables you to add entries, and removeObject for key lets you remove entries from the dictionary. So before setting up this dictionary of preferences, the first thing we need to decide is where we plan on gathering and then using the preferences. In the MyWorld sample app that we're building, The preferences are the text for the following words, the animated words, and the speed for the animation. The place to gather the preference settings from the Settings app is when the app loads, and that's in the app delegate code here. Application did finish launching with options method. However, in mainviewcontroller.m, we've already added code that sets following words to Peace on Earth and the speed to 10. We will have to remove this code from mainviewcontroller.m as we add the new code to the app delegate. Another obvious place to gather the preferences data is in the flipside view, which will be this code here, the viewDidLoad method. Here we will let the user enter the replacement text for following words and change the speed. Both accessing and updating a preference is really easy, as long as you have NSUserDefaults by your side. The trick here is to use the NSUserDefaults class to read and update the replacement text and speed. NSUserDefaults is implemented as a singleton, and that means that you have only one instance of it running in your app. To get access to that one instance, you invoke the class method standardUserDefaults. The standardUserDefaults returns the NSUserDefaults object. As soon as you have access to the standardUserDefaults, you can store data there and then get it back when you need it. To store data, you simply give it a key and tell it to save the data using that key. The way you tell it to save something is by using the setObjectForKey method. The first argument of that method, setObject, is the object you want NSUserDefaults to save. This object must be NSData, NSString, NSNumber, NSDate, NSArray, or NSDictionary. In this case, we're using a string, Peace on Earth. The second argument is for key. To get the data back and for NSUserDefaults to know where to save it, you have to be able to identify it to NSUserDefaults. You can, after all, have a number of preferences stored there in the NSUserDefaults database, and it's the key that tells NSUserDefaults which one you are interested in. The particular keys we'll use are K words of wisdom for the following words replacement text, which you see here, and K speed for the animation speed, as well as K max speed for the maximum speed possible. We're going to use the maximum speed possible because we're assuming that we're going to use a slider on the flip side view to set the speed, and therefore the maximum speed will be the far right point on that slider. To use these keys, K words of wisdom, K speed, and K max speed, we need to define them in a constants.h file. To implement the constants.h file in a project, we select the project name at the very top of the project navigator, and then choose New File from the File menu. The Choose a Template dialog appears, showing the last thing we may have chosen. Now what we want to do is choose Other under iOS on the left side, and then choose Empty in the main pane. Then we click Next. Now the Save dialog appears. The Add to Targets list in the Save dialog should already be set to the name of the project, and here it is set to My World. We want to name the file constants.h and then click Save. And the new empty file is saved in the project. So now all we need to do is add the constants we need right here in the source editor for constants.h. But we need to define these keys. Define K words of wisdom at words of wisdom preference. We want to define K speed, and we can use tab keys to make it look prettier, at speed preference. And we want to define K max speed. We want to define the maximum speed at 20.0. So now we have our constants file, which is great, but we still have to make our app know how we plan to use it, which is the code we will add soon. Now let's not forget to save so that we save the data we just typed into the constants.h file.